This is Dr.T.Vigneswaran, Professor, School of Electronics Engineering, VIT, Chennai. Today, I am going to talk about 8051 microcontroller architecture. So, in this chapter, we are going to see the organization and architecture of 8051 and RAM ROM organization, and finally machine cycle of 8051. Intel MCS 51 microcontroller. So it is commonly termed as 8051. It is a Harvard architecture and CISC instruction set, and it is single chip microcontroller developed by Intel in 1980. Intel's original MCS 51 family was developed using N-type metal oxide semiconductor technology, that is NMOS technology, but later version 80C51 used complementary metal oxide semiconductor technology because this technology consumes less power. The general features of 8051 microcontroller are: it has 8-bit arithmetic logic unit, hence it is mainly an 8-bit microcontroller. It has dual 16-bit address bus, that is 2 into 2 power 16 memory location, which is equal to 64 kilobytes, each of RAM and ROM. 128 bytes of on-chip RAM is available in 8051 and 4 KB of on-chip ROM is available in the microcontroller. It has 4 8-bit bidirectional input and output ports, and it supports serial port, and it has two 16-bit timer and counters, and it operates in power saving mode. It has Boolean processor with 17 instructions, including multiplication, division, and compare instruction. There are 4 fast switchable register banks with 8 registers in each bank. There are fast interrupt with optimal register bank switching. Interrupts and threads with selectable priority is also available in 8051. So this is the different types of 8051 families and their ROM RAM sizes. It is given in the table. So this is the 8051 family series. Because the 8051 is available in different memory types such as UV, EEPROM, flash and NVRAM, all of which have different part numbers. The UV EEPROM version of the 8051 is 8751. The flash ROM version is marketed by many companies including Atmel Corporation and Delos Semiconductor. The Atmel Flash 8051 is called 8089C51, while Delos Semiconductor calls it is DS89C4XO. The NVRAM version of the 8051 made by Delos Semiconductor is called DS5000. There is also an one-time programmable version of the 8051 made by various manufacturers. So these are all the list of major manufacturers of 8051. Atmel, Analog Devices, ST Microelectronics, Dallas, Maxim, Silicon Labs, Texas Instrument, Microchip, and Zylab. So these are the different 8051 Atmel series, and this is the Delos series. Then this is the schematic of 8051. So in this schematic we are seeing the system inputs, control signals and ports from 0 to 3. so which is connected to external world interface. This is the architecture of 8051. So it has CPU unit, external memory control, interrupt control, 4K program memory, and 128 bytes of RAM, then two timers, timer 0 and timer 1, four IO ports, each ports having 8 bits, so totally 32 lines, then serial input and output. So it is 40 pin DIP package. So the pin number 1 to 7 represents port 1, then pin number 8 is reset, then another 8 pins are port 3, then x1 x2 external crystals connected to x1 x2, and the 20th is grounded. Then from 21 to 27 it is port 2 and preset ALE signal, then port 0, then VCC. This is the 40 pin 8051 microcontroller Intel IC. So this is the architecture of or connection of CPU with different ports, as well as RAM, ROM, timing, counter, interrupts, serial port, and watchdogs. This is next to the pin description of 8051. Pin 40 VCC is the main source power. Usually the source required is plus 5 volt. Pins 32 to 39 known as port 0, 0.02, P0.7. In addition to serving as in IO port, the lower order address and data bus signals are multiplexed with this port. This is a bidirectional IO port, and external pull-up resistors are required to function this port as IO. Pin number 31 is ALE, address latch enable, is used to demultiplex the address data signal of port 0. Pin 30, it is external access input, is used to enable or disable external memory interfacing. So the EA signal control the external memory interfacing. If there is no external memory requirement, then this pin is pulled high by connecting it to BCC. Pin number 29, it is program store enable, is used to read signal from external program memory. It is also used for external program memory. Pins 21 to 28 known as port 2, that is P2.0 to P2.7. In addition to serving as IO port, higher order address bus signals are multiplexed with this quasi bidirectional port. Pin number 20, that is VSS, it represents the ground, that is 0 connected to this point. Pin number 18 and 19 used for interfacing the external crystal to provide the system clock. 10 to 17 known as port 3 also serves some other functions like interrupts, timer input, control signal for external memory interfacing, serial communication, and transmission and reception. Pin number 9, it is reset while the microcontroller is working or at the initial start of the application. The reset pin must be set high for 2 machine cycles. Pin number 1 to 8 known as port 1. Unlike other ports, this port does not serve any other functions. Port 1 is an internally pulled up quasi bidirectional IO port. Then 8051 IO ports. So it has 4 IO ports of each comprising of 8 bits, which can be configured either as inputs or output. Total of 32 input and output pins, the microcontroller to be connected to the peripheral device are available for the use. Pin configuration, whether it is to be configured as an input, then you set that particular pin as 1, or output, if output, then you set that particular port as 0, depends on its logic state. This is the port connection. Port 0, which is characterized by two functions. If external memory is used, then the lower address byte is applied on it. Otherwise, all bits of this port are configured as input and outputs. Unlike other ports consisting of pins with built-in pull-up resistor connected by its end to 5-volt power supply, pins of this port have this resistor left out. Then the organization of 8051. So basically the 8051 memory is classified into two types. One is program memory and another one is data memory. The program memory is used to permanently save the program being executed, while the data memory is used for temporarily storing data and the intermediate results created and used during the operation of the microcontroller. Depending on the model in use, at most a few KB of ROM and 128 or 256 bytes of RAM is used. The first model of 8051 microcontroller family did not have any internal program memory. It was added as an external chip separately. These models are recognizable by their local label beginning with 803. All later models have a few kilobyte ROM embedded. Even though such an amount of memory is sufficient for writing most of the programs, there are situations when it is necessary to use additional memory as well. So this is the memory organization of microcontroller and additional ROM memory. So how to interface microcontroller with the additional ROM memory. So in this case, if EA equal to 0, in this case, the microcontroller completely ignores internal program memory and executes only the program stored in external memory. If EA is 1, the microcontroller executes first the program from built-in ROM, then the program stored in external memory. Next, data memory. So the 8051 has 128 bytes of internal data memory and it allows interfacing external data memory of maximum size up to 64 kilobytes. The total size of data memory can be up to 64K external plus 128 bytes internal. There are three separations of the data memory. One is register bank, second one bit addressable area, and third one scratch pad area. So from 00H to 1FH represents 32 general purpose registers, and 20H to 30H it is bit addressable area, and 30H to 7FH is the general purpose scratch pad area. So it is totally 80 bits and the bit addressable areas are 16 bytes and the 32 general purpose registers are 32 bytes. So the address of each register bank is given. From 00 to 07 it is register bank 0, then 08 to 0F register bank 1, 10 to 17 register bank 2, 18 to 1F register bank 3, from 20 to 2F it is bit addressable RAM, and 30 to 7F it is scratch pad RAM. This is the register bank organization of 8051. So the totally there are four register banks: bank 0, bank 1, bank 2, and bank 3. So the corresponding addresses are given. For bank 0 is 0 to 7, for bank 1 8 to F, bank 2 10 to 17, and bank 3 18 to 1F. So each bank registers are accessed by sending the particular address to the bank. At a time, only one register bank is selected for the operation, and the registers inside the selected bank are accessed using mnemonics. By default, the register bank 0 is selected. The bit addressable area is usually used to store bit variables. The bit addressable area is formed by 16 bytes next to next register banks. They are designated from address 20H to 2FH, totally 128 bits. Each bits can be accessed from 00H to 7FH. Within this 128 bits from 20H to 2FH. Bit addressable area is mainly used to store bit variables from application program like status of an output device like LED or motor, etc. We need only a bit to store this status, and using complete byte addressable area for storing this is really bad programming practice since it results in wastage of memory. The scratch pad area is the upper 8 bytes which is used for general purpose storage, and it is from 30H to 7FH, and it includes stack 2. Special function registers are a sort of control table used for running and monitoring the operation of the microcontroller. Each of the special function register as well as each bit they include has its name, address in the scope of RAM, and precisely defined purpose such as timer control, interrupt control, serial communication control, etc. Even though there are 128 memory locations intended to be occupied by them, the basic core shared by all types of microcontrollers has only 21 such registers. Rest of the locations are intentionally left unoccupied in order to enable the manufacturer to further develop microcontrollers, keeping them compatible with the previous versions. So this is the memory organization of SFRs. Next, it is very important one, A registers. So it is the accumulator. Data to be moved from one register to another must go through the accumulator. In other words, A register is the most commonly used register. More than half instructions used by the 8051 microcontroller. Then B register, mostly B register is used for performing multiplication and division operations. All other instructions in the program can use this register as a spare accumulator. Again, R register, it is R0 to R7. This is a common name for 8 general purpose register from R0 to R7. They occupy 4 banks within RAM. Similar to accumulator, they are used for storing temporary variables and intermediate results during the operation. Which one of these banks is to be active depends on the 2 bits of the PSW register. So this is the R registers. Then PSW register is very important special function registers. So it contains 8 bits, parity bit, overflow, RS1, RS0, flag register, then auxiliary carry and carry. So P is nothing but parity bit. If a number stored in the accumulator is even, then this bit will be automatically set 1, otherwise it will be cleared, that is 0. Overflow occurs when the result of an arithmetic operation is larger than the decimal value 255, and cannot be stored in one register. Therefore, the overflow condition causes overflow bit to be set, otherwise it will be cleared. Then RS0 and RS1, it is used for selection of the register bank in the memory. So if the RS1 and RS0 both are 0, then bank 0 is selected. 01 means bank 1 is selected. 10 means bank 2 is selected, and 11 means bank 3 is selected. F4, that is flag O, this is a general purpose bit available for use. Then auxiliary carry flag is used for BCD operations. CY carry flag is the auxiliary bit used for all arithmetic operation and shift instructions. Then another one register is called DPTR, but it is not a true one because it does not physically exist. It consists of two separate registers, DPH, data pointer high, and data pointer low. For this reason, it may be treated as 16-bit register or as two independent 8-bit register. These are all primarily used for external memory addressing. The DPTR register is usually used for storing data and intermediate results. So this is the structure of DPTR, DPH and DPL. DPL represents from bit number 0 to 7 and DPH from bit number 8 to 15. The next one, stack pointer. So the value stored in the stack pointer points to the first free stack address and permits stack availability. Stack pushes means increment the value in the stack pointer by 1, otherwise stack pop means decrement the value by 1. Upon any reset and power on, the value 7 is stored in the stack pointer, which means that the space for RAM reserved for the stack starts at this position. Then P0, P1, P2, P3 input and output registers. Again it is each one is 8-bit port, which is configured as input or output. If the pin is set, if the port is set, then it is act as the input port. If the port is cleared, then the particular port is act as the output port. Then machine cycle. The machine cycle is the minimum amount of time in which a single 8051 instruction can be executed, although many instructions take multiple cycles. The machine cycle is a 4-process cycle that includes reading and interpreting the machine language, executing the code, and then storing the result. A cycle is in reality 12 pulses of the crystal of 8051 microcontroller. That is, if an instruction take one machine cycle to execute, it will take 12 pulses of crystal to execute the particular instruction. Since we know that the crystal is pulsing 11.059 megahertz times per second, and that one machine cycle is 12 pulses, we can calculate how many instruction cycles the 8051 can execute per second. So 11.059 by 12 is 921,583, and 1 by this value equal to 1.085 microsecond. Therefore, one instruction cycle is nothing but it takes 1.085 microsecond. That means 8051 can execute 921,583 single cycle instructions per second. For example, if you are using exclusively 2 cycle instructions, you would find that the 8051 would execute 460,791 instructions per second. Also has 2 really slow instructions that requires full 4 cycles to execute those instructions. You would find performance to be about 230395 instructions per second. So that's all about 8051 microcontroller architecture and its memory organization in 8051, and what is the machine cycle and how it can be calculated. Mainly the machine cycles are calculated because if you want to generate the clock signal for the various applications, we need machine cycle of each instruction. Then only we can find out how much time takes by each instruction, so that we can set the delay for the generation of the clock. Thank you.